Welcome back to a new Visualing Math with Minecraft, and last time we looked at visualizing numbers 2 and 3-dimensionally by thinking about their factors, and I want to expand on that idea. So basically, I kind of felt like I had an epiphany, although I don't know if it was really an epiphany, when I was thinking about how we could simplify radicals, but think about it 2-dimensionally. So here's what I mean by that is 1 squared is 1. And so that means that the square root of 1 is 1. We could do 2 squared is 4, which means that the square root of 4 is 2. And you can see we can make a square out of 4 squares that is 2 by 2. So in theory, if we have a number that we don't know if it's a square root, I don't know that this is a really great way of doing it, but if we had a number, we weren't sure that it had a square root, we could attempt to just make a square out of that many boxes. Here's 9. The square root of 9 is 3 because 3 times 3 is 9. So what this got me thinking about is, what about numbers that are not perfect squares? So what about, for instance, the number 8, which is not a perfect square? Well, so the first thing is, how should we actually, represent it? Because it doesn't have the ability to be a square. Like, if I try, I guess I could try doing it like this, right? So it's 1 shy of 9. This does not make a square. So then my thought was, okay, well, is there some way to relate how many squares are in here with what the answer is? Okay, so I don't know that this is going to be a way for you to actually figure out simplifying square roots if you don't get them right now, but check this out. Whenever we do square root of 8 and we simplify it, we look for the perfect squares that are inside of 8, or we make a factor tree and look for pairs of numbers, and the answer we end up with ends up being 2 radical 2, or 2 square roots of 2, because you can square root the 4 that's inside of 8, but you can't square root the 2 that's left over. Well, look what I noticed here. I'm gonna just color over these. We have 2 squares inside of 8. 2 4s inside of 8. So I was like, well, wait, so that kind of suggests, if we square root the 4 and we get 2, and there's 2 of them, then we've got 2 square roots of 2. Now, it actually ends up being kind of backwards from what we might think. Let's look at a different number to help out with this. I'm going to use relatively small numbers here just because of how annoying it is to count blocks. So let's think about 12. Now, I already know what 12 simplifies to be. Square root of 12 simplifies because it has a 4 inside and then a 3 left over. So you square root the 4 and get 2, and then the 3 is left over to stay inside the square root, so 2 square roots of 3. Now, let's try to visualize 12 and see what connection we maybe can make. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's 12 squares. This is 2 by 6. And what we could do is we could say, well, look, again, we have sections that we can mark off that are squares of 4. And how many of those do we have? 1, 2, 3. We have 3 sets of 4 squares. So this seems completely backwards to me in some way, because the 3 is what ends up inside the square root, and then we square root the 4 and get 2, so that is what goes on the outside. But I just thought this was really cool whenever I realized that this was happening. I want to try doing it the other way, because there's more than one way to actually represent this. So the other way to represent 12, or another way, not the only way, is to do 4 by 3. So if we're looking for a perfect square this way, it's a little bit trickier, because yeah, we could actually find a 9 in here, right? But we can't fit multiple 9s in here. So what we're looking for is a perfect square that repeats itself inside. And so the easiest way to do it is going to be to do 2 by something if it's even, 3 by something if it's not even, and then kind of go from there. Let's pick a really big number just, for fun. Okay, I'm going to pick a medium-sized number. And this is not actually one that I've done yet. So yeah, I'm going to pick 48. So here we go. Let's see. I'm going to start here. Now, 48, if I think about this hard enough, I know what actually goes into it. There's probably a bunch of different ways we could do it. We could do 2 by 24, but I have a feeling that something bigger than 4 goes into 48. That's a perfect square. So we could try doing something bigger. What's the worst that can happen, right? Like, the thing is, 2 goes into 48, 3 goes into 48, 4 goes into 48. So I don't know. We could just what would happen if we made it as even as possible? So 48 is almost 49, which is the square root of 7. So let's do like 7 by 7, but with 1 missing. 1, 2, 3, 4, 5, 6, 7. I have no idea if this is going to work out for us or not. So okay, so this is 48. We're trying to figure out how many perfect squares can we fit in here evenly, right? Well, what's maybe a strategy I could come up with here? If I took this side off and instead put it over here, I feel like that would give me an actual rectangle, and that seems like a better place to start than this. I don't even know what shape this would be. Right, so 1, 2, 3, 4, 5, 6 by 8. Okay, so we need to be thinking about squares. So let's see. 4 is an easy thing to use. Let's see how many sets of 4 fit, or does this fit? I guess would be the other way of looking at it. No, I'm not just doing this because I like how colorful it is. It's a happy coincidence. I feel like it's gonna bother some people that I'm running out of colors and had to repeat, but you know what? I think it still looks good. Okay, so what do we find here? We've got how many sets of 4 here? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Okay, so what that means is that right now we've got 2 square roots of 12 happening. Okay, but wait, I think I've noticed something because of how I have this spread out. Notice, right, that we could instead change maybe this section into a group of 16, this section into a group of 16, and that's helpful because that is also a perfect square. So let's do that. Let's change this up. Oh, no. Okay, so this is a group of 16. The square root of 16 is 4. So this... again, this may end up bothering you, but here's going to be my 16 right here. Okay, so we've got a 16 and another 16, but then the question is, what about this other part? Well, if I move these 2 squares down here, then I've got another set of 16. Let me do that. So let's see. All right, so what we've got here is 48 squares because we had 16 plus 16 plus 16. And so these squares are groups of 16. The square root of 16 is 4. We've got 3 of them, so 48 simplifies to be 4 square roots of 3. This does not seem like the best way to work this out. I just thought it was a really cool thing to visualize. And I am curious if there is some, pattern that we can come up with or algorithm that we can find to make it easier. Because, what if we have 100 something? What should we do? 150 maybe? But I don't think there's enough room here. Why can't I make squares in the middle of the sky? Because that would be cool. Where should I go? Actually, honestly, this is probably the best place over here. A polar bear! Hey, polar bear, do you want to do some math with me? Hey, Mr. Polar Bear, I'm doing some math. Hello. Oh, he's trying to snuggle. Bye-bye, oh, there's a bunny. Why does the bunny have red eyes? Is that a demon bunny? Okay. Let's see. I don't want to do 150. I don't want to do that many squares and then end up having to change it. Okay, so 1, 2, 3. Actually, also, what I need is... Okay, that's a little easier to tell. Okay, so when we're thinking about 150 and how this is going to break down, right? We know 5 goes into 150. So 5 by 5 seems like a good place to start here. And like I said, I don't think this replaces actually knowing how to... I don't think it's a good replacement for how to simplify radicals, but that's 25, right? So then there's more... We can fit more 25s into 150, right? 4, 5. This is 50. Well, how many of these fit inside, right? Well, 6 of them would. So I feel like in some ways this is a little tedious because I already know what this is going to end up being. I know 25 goes into it. I figured out it goes in 6 times. So this ends up being square root of 25, which is 5, square roots of 6. But visually, I do think this is neat, that what's happening is that, right, we have 6 blocks of 25 inside of 150. So see, this is 4 times 25, which is 100. This itself is a square, but because we can't do 100 times a normal number to get 150, that's why that's not what we're picking to use. So all right, so this is 150 blocks right here. Sometimes it's weird because it's like, well, that doesn't actually seem like that many after all. And then this ended up being 10 by 15. We also could have done it as 5 by, what would that be? 5 by 30. And that would have worked. But here we go. We've got 6 sets of 25. So 5 square roots of 6. Let me know what you think of this. I just thought it was interesting as I was trying to visualize how to think about square roots and things like that and how that would work in Minecraft. And I hope you find it interesting too. If you do or don't or whatever, let me know. Like the video, comment, subscribe, all that jazz. Thanks. Bye.